All right. I'm gonna go ahead and start sort of informally start class for a couple of minutes early as people are trickling in. Good afternoon, everyone.
Good afternoon.
Hope everybody had a good weekend and you're ready, willing, and able for your first full semester of first full week of general anatomy and physiology. Okay. Now, Mike informed me that he was putting together. Okay, I'm sure you can read it anyway. But he was putting up a Facebook study group page. Okay. Now, I just got into Facebook a few weeks ago, right? So I'm on the steep portion of the Facebook curve. Okay. I didn't create this. I've sort of been like, well, okay, I don't know what I'm getting into, but okay, I'll sit here and wait and see. And so, Mike, why don't you talk a little bit about this Facebook page that you created, right? And Chuck's Chimps, right? He came up with that, right? Not me. So that's my discussion. So you want to tell the group what it's about, why you put it together. It sounds really interesting. Something I should have done semesters ago. Yeah. So I'm gonna be learning like everything. I could probably do
that. Like it was too long to put on a YouTube account, so then we had study groups this morning.
This is just something we all have the media, we all have the ability to get there, we can all use the page. Somebody here misses a class, failure of note taking. This is what we can make up for. We have questions on the assignments. We want to get together, go study face to face. We want to do whatever. We have this technology, this media. Let's use it. And that's the idea. Real simple. You want to use it as a dating game, stay somewhere else. You want to use it as a study guide, this is what it's up to.
And this is, in short, this is created by students, for students. I'm not making any commitment because of how often I view it, or I assume maybe I've been created on it.
Yeah, it's a closed group. Everybody sent me an email or gave me their email address. I shot that out this morning. I didn't get to create it until this morning. Sorry, I'm an idiot. But it's up and it's running. It's a closed group. You just check on it and you'll be automatically thrown in. It's a closed group. Keep the spam and whatnot down. So, just a meeting.
Do you want me even at all?
By all means. Please.
Okay, because I have no problem staying away if this is for you.
Either here or there.
No, if the crash is 50 o'clock behind your back, you can at least do it to your face.
Oh, okay. Students have no problem doing that. Okay, cool. All right.
Miss Machie's just talking about the Facebook page.
I've never been involved with a Facebook page for class.
This is something I'm experimenting with this semester, and I figured, what the hell.
Okay. Well, not sure where we're going, but it's going to be interesting getting there, right? Okay, if you have your student commitment forms, you haven't turned in yet, you can pass it to your right. I got my directions right that time. Okay. Also, I am officially met. Yes. That's what I was going to say. You didn't remind me that I didn't do attendance, right?
Oh, yeah.
I'm forgetful. I forget things.
I want these other stuff in there.
So, here's the attendance sheet, right? And give me your name, even if you wrote your name in last week, because I didn't revise this what I found.
Yeah, but they might think that this caused it.
So just add their names, right, without looking at these. Okay. All right, thank you. If you have these student commitment forms, pass them to the right. Pass them to the right. Pass them to the right. Okay. Before we go forward, let's take a step back. Right? What did we talk about last week? Raise your hand and tell me what we talked about. At least one thing. Right? What's one thing we talked about?
The 11 organ systems.
We talked about the 11 organ systems, right? We said we stated them, major organs, major functions. What else? Okay, we defined anatomy and physiology, and we talked about how they're related to one another, right? Form follows function, function follows form. What else? Necessary life functions like metabolism, reproduction, digestion, etc. Okay? Alright, I think there's one other thing related to necessary life functions.
The 6 levels of structural organisms.
I was wrong. There are 2 things, right? Levels of organization from molecules, well, for animal molecules at the chemical level, all the way up to the organism level, right? And one other. Survival needs, right? What we have to have in order to maintain those life functions. Okay? You can have in your head, right, the list of things that we went over. Okay? You should have a pretty firm idea of what we discussed last week. Right? Okay? If you're studying the right way. Okay? You should have this mental picture of where we have been, what we've been studying. Right? If you don't, if you've been studying, I mean, if you really, like, you put 2-3 hours this weekend, right, and you can't list those out, it means that you're so into the details, you're so into the trees, that you can't see the forest. You literally can't see the forest from the trees. Okay? Right? You have to know, right, why am I studying this information? What is the big picture? Right? Otherwise, all those details will not mean anything to you. Okay? Alrighty, so we're going to start where we left off on Friday. Alright, we'll talk about homeostasis. Okay? Homeostasis is very important. Right? If the body is not in homeostasis, if homeostasis is not maintained, one becomes sick, and depending on the homeostatic imbalance, can die. Okay? So, we're going to define what homeostasis is. Then we're going to examine the components of a homeostatic mechanism, which is responsible for maintaining homeostasis. Then we're going to explain what a negative feedback mechanism is, and then what a positive feedback mechanism is. Okay? Alrighty, so a good way to think of homeostasis is it's maintaining the internal environment in very narrow limits, right? In a state of dynamic equilibrium, right? Maintaining the internal environment of the body in a state of dynamic equilibrium. Okay? So 2 days from now, I'll ask you, what is homeostasis? You'll say, it's maintaining the body in a state of dynamic equilibrium. Then I'll ask you, well, what does that mean? And you'll say, I have no idea. I just memorized it. Right? Some of you do it, right? Okay. So let's break this word down. Dynamic equilibrium. What does that mean? All right? What am I talking about? In your own words. Anyone have an idea? Oh, go ahead.
I would say like your body temperature, the
example of one.
Yeah.
Okay.
Like your body, I guess its normal range of where it should be.
Okay. Very good. Dynamic. What does dynamic mean? Constant?
Changing.
It's change. Dynamic, pretty much. It's change. It's dynamic, it changes. Right? Now, there's several definitions of dynamic, right? But the one that's being talked about here is change. Right? Okay, equilibrium. What do you think about some equilibrium? About equilibrium. Balance. Right? Balance. Okay. So for the thousands, I guess, of different factors in any portion of your body, right? You have what the perfect value would be, right? Like for body temperature, it could be 98.6, right? But your body is not static. You are not at 98.6 every second of every minute of every day of the year, right? You're not even at 98.6 24 hours a day. Your temperature changes, right? At any given time, it's going to be somewhere around the average value, right? It's going to oscillate over time with different activity levels, different environmental temperatures, right? Different hormones which affect body temperature are going to be secreted at different times times a day, etc., etc. So what you would find is if you looked at body temperature, for example, you'd see that it oscillates, so it's constantly changing. It's not static over time. That's the dynamic part. But typically, it oscillates above and below equally around that average value. So that's what I mean by dynamic equilibrium. Not static, right? Dynamic equilibrium. All right. So your internal environment of your body and everything, blood sugar, body temperature, heart rate to a certain extent, blood pressure, what's that already? Calcium levels in your blood, etc., etc. There some value, average value, around which there is a change over time. But that change, if you are in homeostasis is being maintained, it's between some maximum and minimum value. Right? If I took your temperature, your body temperature right now, and you were at 98.9, right? I wouldn't worry so much about it. I'd say, oh yeah, you're in the normal range down here, right? Or if you were 98.2, right? Don't worry about it, right? On the other hand, if you were 95, all right, that'd be a cause of concern. That'd be out of the normal range, okay, for body temperature, right? So, all of your organ systems, all 11 of your organ systems have multiple mechanisms, what we call homeostatic mechanisms, to maintain homeostasis, to maintain all the various functions of your body within at the normal range. Okay? That's what we mean by maintaining the body in a state of dynamic equilibrium. It's not static, right? It's not a flat line, there's change, right? But all of the various factors are within a very narrow range. Okay? And when you have labs done, right, whether there's blood taken or there's a urinalysis done or when your vitals are done, right, whether you are normal or something is abnormal, right, is really whether or not whatever the value is, if it's in that normal range or outside of that range. If it's outside of that range, then maybe there's a condition that needs treatment. Okay? Alright, so as I said, homeostasis has to be maintained in order to maintain, well, essentially maintain life and also to maintain the body in a healthy condition. Right? If your body is outside of homeostasis, you have what's called a homeostatic imbalance. If your body temperature is too high, or your blood pressure is too high, or your blood sugar level is too low, etc. All those can cause health problems. And if they're severe enough, they can cause death. Okay? So you have all these different homeostatic mechanisms to maintain your body in homeostasis. All right? Okay. And this figure from your book illustrates the basic components of a homeostatic mechanism. All right? And you are expected to be able to explain how a homeostatic mechanism works. Okay? So let's get to it. All right, so the little teeter-totter here is meant to show some variable, right? It could be body temperature, it could be blood pressure, it could be blood sugar, it doesn't really matter, right? Some variable. If it's in balance, you have this nice balanced teeter-totter, right? If it's out of balance, all right, what do you mean? Sure, if there's an imbalance, the teeter-totter is slanted. All right, that's what this portion is showing. Okay, so a homeostatic mechanism is responsible for maintaining homeostasis, maintain balance, okay, of some variables, right? Homeostatic mechanisms contain the following components. One, you have to have a receptor. You have to have something that detects the variable. That detects that the variable is out of balance. That's a receptor or a sensor. Right? We use those two terms interchangeably. A receptor or a sensor. Right? So when there is a change or a stimulus, remember a stimulus is a change. Right? The sensor or receptor detects the change. It then communicates information about that change to a control center. Right? And it sends that information along what's called an afferent pathway. efferent when they think of approach. Information is approaching the control center. The control center is like Big Daddy or Big Mom, right? The manager. It receives the information. It integrates that information, right? It could be receiving other information, other mechanisms as well, and integrates all the information and makes a decision. It then sends a command along an efferent pathway to an effector, causing some change in that effector. It can increase the activity of that effector, it can decrease the activity of that effector. But typically, the change to that effector will attempt to bring this imbalance back into balance. Okay? Yes, ma'am.
Can you explain an example based on body temperature?
In a moment. Okay. In a moment, I certainly will. Okay. Right now, what I want to do is talk about something that you're all very familiar with, which is a household thermometer. Right? It is a household thermostat. Excuse me. It is basically a homeostatic mechanism. Okay. By the way, I should say, skip over this. Most homeostatic mechanisms work by negative feedback. That is, the activity of the effector tries to bring the variable back into balance. Well, what caused the effector to be turned on or changed in the first place? Well, it was the stimulus, right? This imbalance. So the effector is taking action to reduce or remove the stimulus that caused it to come on in the first place. Right? It's self-limiting, so to speak. All right? Right? That's what's meant by negative feedback. All right? The example I want to use is a household thermometer. All right? So, here the variable is temperature. Right? So let's say you're at home. It's a nice, cold January day in Wisconsin. Okay? And the wind blows, it opens a window. Right? The window opens and the heat starts going out, cold starts coming in. Right? Let's say you have your thermostat set at 70 degrees Fahrenheit. Right? That's the set point. All right? That's the temperature it's supposed to be in the house. Okay? Window blows open, hot air goes out, cold air comes in, drops the temperature to 68 degrees Fahrenheit. Okay? There's a thermometer in the thermostat that detects that drop in temperature. Okay? That's the receptor for sensors. It's detected that change. Right? And it communicates that to the control center in the thermostat. Right? Basically it's saying it is 68 degrees in here. Right? Thermostat compares the actual temperature to the set point, what it's supposed to be. It's supposed to be 70. Then it closes a circuit that turns on the effector, the heaters. Right? Heaters kick on. Boom. Right? Starts kicking out heat. Hopefully someone's smart enough to close the window. Right? But with that extra heat now being produced, that will at least attempt to get the temperature back up to 70 degrees. Alright? When that 70 degrees is achieved, now the stimulus that caused the effector to come on in the first place is now gone. So what happens to the heaters? They kick off. Right? Now all of you are familiar with this. Right? I mean, you're all familiar with this. Right? You know how this works. This is negative feedback. Okay? What makes it negative feedback is the activity of the effector reduces or removes the stimulus that caused the heaters, the effector, to come on in the first place. Okay? All right. Now, let's go to the example of body temperature. Okay? And don't worry about the details with the skeletal muscles, the hypothalamus, and heart stuff, right? Okay? It's the concept that I want you to understand. Okay, what happens when you get cold, right? Your body temperature drops, let's say it drops to, the core body temperature drops to 98. What will typically happen? shiver. Okay? This is what's happening. Body temperature drops. There are receptors inside your body that detects a drop in body core temperature. And it communicates it to the hypothalamus. Right? It says it is 98 degrees here in sunny Jessica. Right? Hypothalamus says, well, it's supposed to be 98.6. This is not a good situation. You got to heat Jessica up. Right? What does the hypothalamus do? Hypothalamus causes the skeletal muscles to contract. Right? And you shiver. Okay? When skeletal muscles contract or shorten, they use energy. Whenever you use energy, a byproduct, a certain portion of that energy is lost in heat. Right? That's why when you run, when you do anything where your muscles are contracting a lot, you generate a lot of heat. It's a byproduct of just utilizing energy. Right? And that, hopefully, that production of extra heat will help raise your temperature back up to normal. And if it does, you stop shivering. Okay? If it doesn't, you continue to shiver. Or someone gives you a cold or something. Okay? Negative feedback because the skeletal muscles, if they're successful, they will reduce or completely remove the stimulus that caused them to be turned on by contracting in the first place. Okay? Most homeostatic mechanisms in your body work by negative feedback, right? For obvious reasons. Okay? Because negative feedback takes the variable back to where it's supposed to be. Right? You eat a candy bar, a lot of sugar, into your bloodstream. Blood sugar level goes up. Okay, what hormone is produced when your blood sugar level goes up? Insulin. What does insulin do? Brings your sugar level back down to normal. Another negative feedback. Okay? Most homeostatic mechanisms work that way. Again, for obvious reasons. Right? Wouldn't make any sense, but for insulin to be secreted when your blood sugar level was high, if it was going to make it go even higher. Right? Okay. We're clear. Okay, now there are some positive feedback mechanisms. Okay, there are certainly fewer of them than there are negative feedback mechanisms, but there are some. Positive feedback mechanisms, their function is to create a rapid change over a short period of time. A rapid change over a short period of time. Okay? And usually they are occurring so negative feedback mechanisms are pretty much the rule, right? They are occurring all the time to maintain homeostasis. Positive feedback mechanisms are the exception, right? They occur for just a small amount of time under a specific situation. All right. For example, okay, you would agree that being pregnant is a temporary condition, right? Versus not being pregnant, right? And for men, we're never pregnant, right? We're not supposed to. Okay. Right? Temporary condition. Okay? The birthing process, right, where you go from small contractions, a lot of time between, to very heavy contractions, one right after another. That whole process, right, is controlled by positive feedback mechanisms. Okay? So, let's say you have a mother, an expectant mother, she's 9 months pregnant, right? So there's a very large fetus in the uterus. And it's creating a lot of pressure, right? Okay? There are receptors in the walls of the uterus that detect that pressure. And they communicate that to the hypothalamus. A lot of pressure down in the uterus, right? Above normal. Okay? Now the hypothalamus receives that information. The hypothalamus is also receiving other information, hormones, estrogen, progesterone, whatever. that the hypothalamus is integrating. All right. So okay, it's the hypothalamus is okay. Well, right, based on all this information I'm getting, 9 months is moving there. Right. So what activity does the hypothalamus initiate? Initiates the release of a hormone called oxytocin. Oxytocin goes into the blood. From the blood, it goes to the smooth muscles of the uterus, causing them to contract. Right? Contraction means to shorten, like how you contract a word from cannot to can't, from do not to don't. Right? Your muscles contract, they shorten. Well, what do you think happens to the size of the uterus if the smooth muscles in the uterus are shortened? It gets smaller. What do you think that does to uterine pressure? It increases even more, which causes more receptors to be stimulated, to send more information to the hypothalamus about even greater pressure, which causes the hypothalamus to secrete even more oxytocin, which causes more contraction of the smooth muscles, so the smooth muscles contract more often and they contract more vigorously, right? Which causes more uterine, a further increase in uterine pressure, more activation of receptors, more release of oxytocin, more contraction of smooth muscles, right? And that's how labor contractions progress from, weak contractions, a lot of time between them, till strong contractions and one right after another, until eventually parturition occurs, baby is born, and then uterine pressure drops back down, way down, more toward the normal. Right? The feedback mechanism ends. Okay? Now, it's positive feedback because the activity of the effectors is moving this variable farther and farther away from the accepted value or homeostasis. Okay? So it creates a rapid change relatively, but over a short period of time. Right? And only under certain conditions. Okay? Looks like you want to raise your hand.
Can you say it's positive because, say that again?
Okay. What makes this a positive feedback mechanism is the effector is increasing the stimulus that was responsible for it being turned on in the first place. See, in a negative feedback mechanism, the effector decreases the stimulus that caused it to be turned on in the first place. Right? With positive, it increases it. Yes.
So the opposite of that, let's say if a negative thing would happen is instead of it making more contractions to make more pressure in the uterus, if it made the muscles loosen
or relax, correct.
That would be negative. Right? The opposite of that?
Well, if that's what the hypothalamus was secreting. Right. Okay, but it's not. That's why this is positive.
Because it says pressure is the stimulus, and it's saying, okay, my effect is more pressure.
Right. The effector causes more pressure.
Right.
So it's increasing the stimulus to cause it to be turned on in the first place.
Okay.
Right. Where negative feedback is the opposite. Right. The negative feedback is bringing the variable back into balance. And once it does that, what turned the effector on in the first place was being out of balance. Yes, sir.
Vomiting will consider positive feedback.
Okay. Why do you say that?
Well, I'm asking because I don't know.
Okay. It would be negative feedback. All right. And what I'm thinking of, typically, all right, are you like alcohol? You drink too much alcohol. Yeah. Okay. Drink too much alcohol. Do you know why you vomit if you drink too much alcohol? Right. Well, yeah. I mean, there's a lot of things. You got too much. You basically are ingesting a poison. Right. It's at toxic levels. All right. So what your body says is, okay, we've got something we're ingesting is getting to our bloodstream and it's causing us harm. Right. Well, vomiting is an easy way to remove that. Remove any of this stuff. Right. So you vomit to avoid it. Okay. Right. Which hopefully that will reduce your blood alcohol levels and you will stop vomiting. Right? It takes a little while. You have to be quite a bit. Right? So that'd be negative. Right? If it's positive, you never stop vomiting. You just keep vomiting. Right? And more vomiting would cause more vomiting. Okay. Right? But also toxic stuff. You get food poisoning. Right? You eat something that you shouldn't because it's been sitting around for too long and you vomit. I mean, again, something toxic that enters your blood, your body recognizes it and then causes you to boil. Okay? Right? Again, most homeostatic mechanisms are negative. There are just a few that are positive. Another positive one would be blood clotting. Right? You have platelets are activated when there's a cut in the a blood vessel. Nearby platelets are activated, which causes them to secrete substances that activate other platelets, which cause them to secrete substances that activate other platelets. Blah, 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 and those platelets all accumulate into a tear. And as soon as that tear is patched, then that mechanism stops. Yes, sir.
How does hemophilia work in that regard?
Well, it's a complicated process, but there are several what are called clotting factors that are involved. For hemophilia, someone is missing one or more of those clotting factors. Okay, right. Homeostasis and homeostatic mechanisms, that is the concept that students understand the least, right, from chapter 1. Right, so if you understand that, then you're more than likely you understand everything in chapter 1. I mean, for the most part, all the other stuff in chapter 1 is not really understanding, right? You just, it's in the book, it's pretty cut and dry, right? Homeostasis and homeostatic mechanisms is a process, right? You have to be able to explain, okay? And that is the topic that students understand the least. So when you leave today, make sure you go over homeostasis, make sure you understand it. Also, I have placed on Blackboard, right, a short online lecture on homeostasis, which is shorter than the one I just went through. You don't have to go through all that. Okay? Yes, ma'am.
Can you identify a homeostatic mechanism? Like, what are the pieces? The hypothalamus is what controls all that?
Okay, no, that was an example. What I want you to know at this point, all right, this receptor, control center, effector.
Because there are many different control centers and effectors?
Right.
Okay.
Right. Okay. I threw these in just for an example that I'm not talking about body temperature if I don't talk about the skeleton. I'm not talking about, birthing process being a positive feedback mechanism. I don't explain the role that smooth muscles have, the role that the hypothalamus has in the control system. Right? Okay. Don't get bogged down in that minutia. What I want you to understand is this: receptor, control center, effector. So no matter what the variable is, whether it's body temperature, it's blood pressure, heart rate, the pH of your blood, the pH of your of the contents of your stomach, calcium levels in your blood, potassium levels in your blood, blood sugar, right? They're all regulated by a homeostatic mechanism which must be able to detect the variable, have a control center to integrate information with decision, and the effector to take some kind of action. Okay? That's what I want you to know. Right? I just had to choose some examples, so I had to get very specific in those examples. Okay? Clear as mud?
Yeah.
Yep. Sir?
Just out of curiosity, the receptor in this case used to be a nerve.
Nerve endings, right? You have different types of nerve endings. You have osmoreceptors, you have pressure receptors. In this case, it's pressure receptors. Right. Okay. Any questions when we move on? Right? Make sure you understand homeostasis, right? Because you are all the organ systems we cover in this class, right? Whenever we talk about controlling different variables, okay, it's all going to come back to homeostasis, and you need to understand how homeostatic mechanisms work. Because homeostatic mechanisms are responsible for maintaining all of the variables of the body in equilibrium, dynamic equilibrium. Okay? Alrighty, so this last portion of the chapter overlaps pretty much with lab. Alright, so here you're going to see a lot of what you saw in lab. But I don't mind the overlap, I don't mind the redundancy, because this information is so important for you to understand, and so helpful for you to be successful the rest of the semesters. I don't mind a little bit. Okay? So, we'll demonstrate the correct anatomical position. We're going to talk about directional terminology and describe relative positions. We're going to define landmarks, or at least talk a little bit about how to study body landmarks. Identify body plans and sections. We're going to look at the cavities and the organs in each one, and we're going to identify the abdominal pelvic quadrants and regions. Okay, so in medicine and in anatomy and physiology, we basically have our own language. All right, we have terminology which we use to be very, very specific about positions, directions, structures, and regions. And we have this terminology to prevent miscommunication among scientists as well as among medical practitioners. Okay? So, when you see that you must learn this terminology in this class, I mean to tell you that you're not having to learn it simply because, well, in an anatomy and physiology class, that's what you do, right? You just can't say up, you have to say superior, right? Because this is an anatomy and physiology class, right? No, because you actually, for those of you who are going into the various medical fields, you will actually use this terminology, right? You radiologists, respiratory therapists, occupational therapy assistants, etc. You will use this terminology over and over again. Okay? Believe me now. Well, hear me now. Believe me later. Right? And remember what I'm saying today a couple of weeks from now. Right? Okay, let's talk about orientation and directional terminology. Right? So, if we want to talk about something that is toward the head, or if we want to describe a location relative to another, we use directional terminology. Something that is toward the head is superior. Something that is toward the feet is inferior. For example, we can say that the nose is superior to the mouth. The mouth is inferior to the forehead. Okay? If we want to talk about position from front to back, we can use ventral or anterior and dorsal and posterior. Okay? And you can use ventral and posterior and dorsal and ventral and anterior and dorsal and posterior interchangeably. Right? Does anyone know what ventral technically means? Stomach, belly side. Right? Ventral means belly side. And anterior is toward the front. Think about where you're walking. Okay? In bipeds, organisms that walk on 2 feet, the belly side and the front are the same. We were talking about a quadruped like a dog, would be 2 different things. Right? Because front, anterior is toward the head, ventral now is facing down toward the ground. But in us, the belly side and the ventral side and the anterior or front are the same. Same thing with dorsal and posterior. Toward the rear, posterior, toward the back side, meaning your back, right? Dorsal are the same. So you can use those interchangeably. Okay. We can describe a position on the body relative to the midline of the body. The midline is an imaginary line that splits the body into 2 equal halves. Something that is away from the midline, we say is lateral. Something that is toward the midline, we say is medial. Right? Pretty easy to remember. Medial toward the midline. Lateral away from the midline. So you can say that the heart is medial to the arm. Okay? Well, the arms are lateral to the chest. You can also describe one location relative to 2 locations farther away and closer to the midline. You can say, for example, the collarbone is, your clavicle here, the collarbone is intermediate to the shoulder and the breastbone. The breastbone being more medial than the collarbone, the shoulder being more lateral than the collarbone. Okay? Proximal refers to the distance from the attachment, and specifically we're talking about the limbs. Okay? Something, a location far away from the attachment is distal. Something close to the attachment is proximal. For example, the wrist is distal to the elbow. The palm is, the wrist is proximal to the palm because the wrist is closer to the attachment than the palm. Alright? Well, why don't we use inferior and superior on the limbs? Why don't we use proximal and distal? Because they move? Right? Now everything is understood based on a common point of reference, which is the body in correct anatomical position. Alright, so we talk about lateral and medial, superior and inferior. We're assuming the body is in correct anatomical position. Right? But this is correct anatomical position, this is correct anatomical position, and this is. Right? So here, not a problem saying, well, this is superior, this location is superior to that. Oh, what about this? Well, which one is closer to the end? Alright, which one's higher? So instead we use proximal and distal. It doesn't matter where these arms are in this plane, right? The wrist will always be distal to the elbow.
So then distal and proximal only refers to limbs.
Only refers to limbs, correct. I'm going to simplify it for this class, yes. Right? There's some ifs, ands, and buts there. Right? As far as this class goes, yes. Okay? Alright? And we use the terminology to avoid confusion. Right? Okay? Because if you turn me upside down, I was standing on my head. Okay? The chest will still be superior to the navel. Okay? If we use words like up and down, right? You stood on my head, right? Two different individuals might have different perspectives on what is up and what is down. Right? But if you accept anatomical terminology and use the common reference of correct anatomical position, right? It doesn't matter if you're if you are looking at a patient and you are at the foot of the bed or the head of the bed on the right or left, it's all the way the same. That avoids miscommunications between medical practitioners. Okay? I should also did not talk about superficial and deep, right? Superficial is toward a body surface. Deep is away from a body surface. Okay? So sometimes you'll hear, there was a shooting and a bullet just grazed an individual, right? And we're talking about it being a superficial wound, right? Because the wound is not very, it's superficial, it's very close to the body surface. Whereas you can have a deep cut where the damage is significant and away from the body surface. Okay? Now, something I also want to point out is we don't have to be talking about the skin when we talk about superficial and deep. Right? Let's say we're looking at an intestine. The intestine. Alright? This is the wall of the intestine. That's what this is supposed to be. The wall of the intestine. This is where the good stuff goes to. This is where the portobello cheese is. Right? Let's say we have a location here. This is A. Location here. This is B. Location here. That's C. With respect to this surface, B is deep to C, and C is superficial to B. Alright? Again, the point of reference being this outer surface here. Right? Likewise, we're talking about this surface here, the lumen, okay, or the layer lining the lumen. A is superficial to B, and B is deep to A. Right? So it really depends on your point of reference. Okay? Let's see. Yes, ma'am.
Yeah. Well, there was a question in one of the study guides about the heart to the sternum. The heart would be deep compared to the sternum, right?
That is correct.
That you could phrase it that way. You could also say the sternum is anterior to the heart.
You could say that as well.
Okay.
Yeah, you certainly could. Right?
Would you say the sternum is superficial to the heart?
Yes. The heart's deep to the sternum, and the sternum is superficial to the heart. Okay. Nope. You'd be correct. Does everybody understand that? Why you can say that? Okay. You could say that the bone here in your upper arm here is the humerus, right? You could say that the humerus was deep to the biceps brachii, right? Because your biceps brachii is right here. You could also say that the biceps brachii is anterior to the humerus. Either one of those would be correct. Okay, body landmarks. All right, now I'm not going to go through all these body landmarks, right? I mean, the book does a good job of doing that for you, right? What I do want to stress is how important it is that you learn these body landmarks, right? Okay, I mean, know them like the back of your hand, because many of the structures that you're going to spend time learning the rest of the semester are going to be named after these body landmarks. Okay, so you do yourself a huge service if you master the body landmarks. Okay? All of them. Right? All of them. And it's not really as bad as you might think. Okay? Now, let me tell you what to do and what not to do. Right? Do not sit down one evening and memorize all of these, or even try to memorize all of them. Right? You will hate that. You will hate me for having to do it. Right? You'll hate it having physiology, or you won't like it as much. Okay? Instead, take a few, right? Each day. Okay? Start at one end of the body and go to the other. Right? Today, just for example, say, okay, I'm going to learn these. Everything on the hand. Right? Just learn those. Right? And use your body as a living model. Right? So cephalic, frontal, right? Orbital, nasal, oral, buccal, or whatever is on there. Mental, things like that. Class to class, right? Just do that a few times, okay? And stop there. And the next day, come back, review those, and add a few more. And then after that, review those and add a few more. Okay? If you go through that process, right, of reviewing the previous material and adding a few more, you will be amazed at how quickly you'll learn this. My daughter is 5 years old. She can tell you almost all of this, right? And the reason why she can is every day, as I'm putting lotion on her and stuff, right? I would give her every few days. I'd give her a new part of the body to remember, just one or maybe two, right? And every day we go over the ones from the previous day, right? And after so many days, get them right. I add another one. Okay, it's not hard. What's important is how you approach learning material. All right, but do not sit down and try to memorize all that in one day. Okay, yes, ma'am.
So the brachial, that's the whole entire arm?
It is the whole entire arm.
Just like the pure.
Well, excuse me. It's not. Well, this is what your definition of arm is. All right. This is the forearm.
Right.
Right. It's everything from the shoulder to the elbow. That is brachial.
Okay.
Okay. So this is brachial. This is anti-brachial. Anti-brachial. Okay.
Yeah.
All right.
I lost track of another point.
No, not a problem. Okay. Something else that's important. Do not just look at the pictures. The pictures in your book summarize the text. Right? And if you just look at the pictures, you may not actually know what you are actually being. You may not actually know what these terms include and don't include. Like if you just look at cephalic from this picture, well, what does cephalic include? Is it the anterior head, or is it the entire head? Well, the reading will tell you it's the entire head. Okay? Do not just rely on the pictures. The pictures and the text work in concert with one another. You use both of them. Okay? All right? So you got anterior, you got posterior landmark. Do what I meant to do. Okay? In some cases, right, certain landmarks refer to both the anterior and posterior foreleg. Femoral is the entire thigh. Right? Popliteal. Is it the posterior knee or is it the entire knee? Right? Okay? You can't know just by looking at this picture. necessarily, right? If you look at the text, it will say posterior knee. The patella is the anterior knee. Okay? So don't just look at the pretty pictures. Don't just look at the pretty pictures. You gotta read the text. And don't just read the text and not look at the pictures. Right? Okay? They're made to work in concert with one another. Okay? But really, commit those landmarks to your to memory. Alright? You can learn them because that will help you so often. If you know where the brachial region is, then it makes it easier to identify. The biceps brachii, the triceps brachii, the brachial artery, the brachial vein, the brachial nerve. All right? I mean, just by knowing that that's the brachial area, you already have at least an idea of where all of those structures like the front left are located. Right? Okay. If you don't do that, it's going to happen for the rest of the semester. I guarantee you. Okay, let's talk about body planes. So, if we want to look at certain organs of the body, we choose a particular perspective or view, right? And we choose that perspective or view based on what it is we're actually trying to look at or see, right? We can take a sagittal section of the body or an organ. A sagittal section separates the body or an organ into a right and left. And again, everything is assuming correct anatomical position. All right? Any section is a cut that separates the body into a left and right is a sagittal section. So it doesn't matter if it's right down the middle of the body, it doesn't matter if it's down, coming across the shoulder, or what have you. They're all sagittal sections. If they separate the body specifically into an equal right and left half, then it's a median section or a midsection. But they're all sagittal. Notice with the sagittal section, you have a good view, top to bottom, or superior and inferior, but you're not going to be able to view anything that is lateral to that section, right? So if you were looking at the body along this plane here, you can see the sternum, you can see the heart, you can see the spinal cord, right? You would not be able to view the lungs, you would not be able to view the kidneys, you can't view anything that's lateral to that section. Okay? Frontal section separates the body into the anterior and posterior. It's also called a coronal section. You can use it interchangeably, right? They provide a good superior to inferior, left to right view of the body. Right? So here you can see, right? You can see part of the shoulders, you can see the heart, you can see the liver, you can see some of the intestines, the stomach, what have you. What you can't view is anything that is anterior or posterior to that section. So you're not going to be able to see the spinal cord, you're not going to see the kidneys because they are more posterior. Lastly, transverse section. Transverse section or cross section separates the body into a superior and inferior portion. Provides you a good cross section, right, front to back, left to right, of that particular, along that particular plane. Okay? But you miss anything that is superior or inferior to that plane. Okay? Alright, it is time to go, so I'm going to let you go. We will finish chapter 1 on Wednesday, and we will start chapter 2, which is chemistry. Make sure that you're checking your email every day, or at least every other day, for updates.
Oh. Yeah, I see the stories.